I've been gone for like 10 seconds. Now let's talk about word problems. And I know people always complain about word problems, but these are not so bad. Um, Really, the biggest thing, kind of like in that last chapter when we were talking about Pythagorean theorem word problems, which every single one just made a triangle, a right triangle. In this one, you're always going to set up a proportion every single time. I always think of it as line equals line, meaning that I'm just going to write a proportion, two fractions, and then all I've got to be able to do is put the numbers in the right spot. And that's the biggest thing. Write your proportions in the right order and then solve by cross multiplying or however you want to do it. So that's why you always want to label things. And there's like a million different types of word problems that we can have. So Roger can eat 8 slices of pizza in 10 minutes. How many could he eat in 34 minutes? How long would it take him to eat 100 slices? And there are many different ways to do this. I know um, Emmett, if you guys know Emmett, 2 years ago, he did it completely different than the way we did, and I can tell you how he always did it. Um, and it worked because that's the one thing I love about proportions is there's so many different ways to get to the same problem. So I always just think of it as I look at the information that I need to talk, that I need to that I'm given. And so the information that I was given in this question is doo 8 slices of pizza, 10 minutes. And then for the first question, it's asking for 34 minutes. So I'm putting an 8 there, and I'm labeling it as pizza because that's what it is. And I know that he finishes it in 10 minutes. So then you're going to put equals, and then it's going to be a line, and then you just got to figure out where does that 34 go? Well, 34 was minutes, and if you see, I put minutes on the bottom here, meaning that minutes also has to be on the bottom here. So you're keeping things in order. And then you would cross multiply and solve. You'd end up with 272 equals to 10x. And then you get dividing by 10, and you get 27.2 pizzas in 34 minutes. So it's literally just writing two fractions and making sure your fractions in the correct order. So the second question is different though, because it asked 100 slices of pizza, so it's a little bit different. So I can still keep 8 pizzas per 10 minutes, but now what's different is the 100 goes on top because 100 was slices of pizza, right? It's not minutes anymore. I'm looking for 100 slices. So that's why the order changed because I gave you different information. Um, so on this one, when you cross multiply, you're going to get 8x equals to 1,000. You're going to divide, and it would take Roger apparently 125 minutes to eat 100 slices of pizza. So about 2 hours. So, and then another type of question has to do with maps, um, which you will do, and it's still just setting up a proportion. That was weird. Still just setting up a proportion. So the scale of a map is 2 inches equals to 225 miles. If two towns are 16.8 inches apart on the map, obviously not in real life because 16.8 inches is like that. I don't think two towns could be that far apart. How far apart are they in real life? So just set up your proportion. And the easiest way, I think, is just to use what's called the scale. The 2 inches equals 225 miles. So I just write that as a fraction, and then I have to think to myself. And I actually think out loud a lot of the times. I know people are weirded out sometimes when people are talking to themselves, but in math, it works really well to talk things out. So 2 inches, 225 miles, 16.8 inches. So inches is on top here. So that means I'm just going to put that 16.8 inches on top because I'm keeping the same order. Then you're going to cross multiply and solve. If you cross multiply, you get 2x is equal to 3,780. Divide by 2, you get x equals 1,890. So with the word problems, literally, line equals line, and then put things in the right order. if I were to give you an actual map, you would have to actually use a ruler to find the scale, because there's usually a little part on the bottom, and then you would have to actually measure how far apart things are. Before I forget, Emmett wouldn't have done a proportion. What he liked to do is find out basically a unit rate, like we talked about. So he would have done something like, well, 8 slices of pizza. How long would that, how much is it per pizza? So he would have done basically something like 10 over 8, which he would have gotten 1.25 minutes per pizza. And then he would have divided 34 by that 1.25 and gotten 27.2. So he converted everything to unit rates and then just used the unit rate. Or he might have done 8 divided by 10, 0.8 pizza slices per minute. And then if he did 34 times 0.8, you'd also get 27.2. So you can do things using a unit rate, which is fine. This last part is what's called a factor label method, and it is not easy. But it's not horrible. It just takes some practice. What it's about is converting units. And I'm not going to show you this whole video, but basically, I don't know if you've ever, apparently I'm just going to show you lots of Mythbusters, but
cars smashing into each other at speed 1x. In 3, 2, 1.
This little thing down here is actually how they're going to calculate speeds. So basically they can time how long it takes, and they know the exact distance. And if you have a high-speed camera, you can measure.
Goes under the hammer.
You can see the little marks. You can measure basically exactly how far it's gone in a certain distance, and then you can use what's called the factor label method to figure that out. So, I mean, it's that simple. It just takes some practice. And like I said, luckily for some of you who care nothing about everything, not everything, getting an A++, this isn't something you have to be able to do. But if you ever want to take chemistry or physics in college, like if you plan on going to college or being a nurse or doing anything, you have to take chemistry, and you're going to have to know how to do this because you do it a lot in science classes. So it's called the factor label method. So it's all about changing units. I'm always just going to give you some unit conversions there. 10 millimeters is 1 centimeter, 2.5 centimeters is 1 inch, 100 centimeters equals 1 meter, 12 inches equals 1 foot, 5,280 feet equals 1 mile, 1,000 meters equals to 1 kilometer. So you're going to use those. So it's going to look weird. So if I asked you to change 7 meters into inches, we're going to do what's called factor label. And it's called this because you're labeling every single unit. And that's going to be the important part, the labeling. So, just so you know, units, which are the inches, millimeters, centimeters, those are units, are always going to be diagonal to each other. You should never have the same label on the same row right next to each other. You might eventually have some based on what you're doing, but you're not always going to have that. So, how this works is you always start off with your first unit. Bloop, bloop, bloop. And we're always going to make kind of this weird little table. I make boxes, and then whatever that first thing was, that's what you start with. 7 meters. Seven meters, and we're trying to turn it into inches. So you've got to kind of look at this and look at inches. Inches converts into feet, but meters has nothing to do with feet. So inches can turn into centimeters, and centimeters can turn into meters. So what we want to do is go from meters to centimeters and centimeters to inches. So 1 meter equals 100 centimeters. So when I say diagonal, you're going to take, oh my gosh, I don't know why. Okay, it lets me draw there. So we're going to take this conversion in blue. I always draw arrows. Bum, bum. 1 meter. So that's what I mean by they're always diagonal equals 100 centimeters. That's a C. Yeah. So, and then I'll explain why that is in a minute. So then we want to figure out the next conversion, which is centimeters into inches. And so this is centimeters, right? Which means we go diagonal, so whatever that centimeters is, we're going to put here 2.54 centimeters, whoop, whoop, equals 1 inch. So, the reason we're doing this diagonally is that when a unit is on top and it's on the bottom, you can cross it off. Meters and meters, diagonal, right? Centimeters and centimeters. What's the only thing that's not crossed off? Which is inches. I'm going to sneeze. Excuse me. Well, you didn't see me sneeze. I paused it. But anyway, the only thing that's not crossed off is inches, and that's what we wanted. So what we're going to do now is you're just going to multiply everything on the top. 7 times 100 times 1 is 700. So I wish I could multiply. And then you're going to multiply everything on the bottom. 1 times 2.54 is 2.54. And then you divide. So if I do 700 divided by 2.54, that's going to give me 275, right? Oops, sorry. 700 divided by 2.54, 275.6. inches. And so, I think that's right. Siri, convert 7 meters into inches.
275.59 inches.
So 0.59, I rounded 0.6. So we're good. Obviously, when you take a chemistry class in the future, they're not going to let you use Siri to do that. So another thing you can do, and this is what they were doing in that Mythbusters, is you can convert units. So that's 20 feet per second into miles per hour. So the question is that fast or not? And it would be following the same steps, except for I only have 1 minute and 30 seconds to try to explain that. Oh, whoa. So, I don't think I'm going to have the time. But, you would start with your box. Bloop. And you start with this, 20 feet. And then here you're going to put per second. And what you're going to basically do is ignore the seconds for now. You're only going to try to do the miles part, and then we'll fix. So if you look over here, 5,280 feet is 1 mile. So diagonally, 5,280 feet. 1 mile. Wow, I just cannot write with the mouse. And then I have 30 seconds off. Then you're going to do seconds. Oh no. Panicking, so slow. And so now it's diagonally, you have to go diagonally up. What do we know? 60 seconds. 1 minute. And then No. Oh, no. No time. I'll have to finish another time.